So hello friend, we are on the last video of this chapter, property of gases for the basic mechanical engineering. For the previous videos you can search on AVM Tech Android, or you can scan this QR code and you can enjoy the free video. So we are talking about sixth video related to chapter number 2, that is adiabatic process. So what is adiabatic process? So an adiabatic process is a thermodynamic process in which no heat is exchanged with the surrounding, means Q is equals to 0. So all the energy transfer occur as work done by or on the system, and the internal energy changes accordingly. In this case what you will observe, Q is 0 and your initial state is with the coordinate P1 V1, final state is with coordinate P2 V2, and the process which is shown here with the curve, this is a adiabatic process where heat transfer is 0. So from the first law of thermodynamics, Q equals to delta U plus W, Q is 0. So change in internal energy equals to minus W. We know what is the formula of delta U, that is mCv T2 minus T1, or you can say W, that is equals to minus mCv T2 minus T1. It is a very simple thing. So now we have to find out what is the formulas for this adiabatic process. So as we know, the polytropic process equation, PV raised to n is reduced to PV raised to gamma is constant, where gamma is the adiabatic index, that is the ratio of two specific heat Cp by Cv. So we can say that P1 V1 raised to gamma equals to P2 V2 raised to gamma. This is also known as the Poisson's law for adiabatic process. That is P1 V1 raised to gamma is equals to P2 V2 raised to gamma. Now, what is the relationship between the temperature and volume in this case? So PV equals to MRT and PV raised to gamma is constant. So we can say that P, that is equals to C divided by V raised to gamma, or you can say that is equals to C divided by V raised to gamma minus 1, that is equals to MRT. Also we know that TV raised to gamma minus 1 is constant, so we will get this relation T1 V1 raised to gamma minus 1, that is equals to T2 V2 raised to gamma minus 1, where gamma is the adiabatic index. What is the relationship between the temperature and pressure? So PV equals to MRT, PV raised to gamma is constant. So in PV equals to MRT, we can rewrite V, volume, that is equals to MRT by P, and also we know that PV raised to gamma is constant. So I can write P, instead of V I can write MRT divided by P from here. Raised to gamma is constant, and upon simplification what I will get P raised to 1 minus gamma into T raised to gamma is constant, or I can tell T2 into P2 raised to gamma minus 1 by gamma, that is equals to T1 into P1 raised to gamma minus gamma, or I can tell T2 by T1 equals to P2 by P1 raised to gamma minus 1 upon gamma. This is very easy to understand and very easy to remember also. You can easily derive this relation for temperature and volume as well as for the temperature and pressure. Now what is the work done? So work done by the gas, that is equals to W, that is integration between V1 to V2 PdV. We know that P, that is equals to C divided by V raised to gamma. So we have to replace this P by C divided by V raised to gamma, and we have to go for integration. and we have to put the value of V by V1 and V2. So what we'll get, W, that is equals to C divided by 1 minus gamma into bracket V2 raised to 1 minus gamma minus V1 raised to 1 minus gamma. And what we know, P1 V1 raised to gamma, that is equals to P2 V2 raised to gamma, and that is constant. So what we have to do is, okay, we have to put these values here and we have to simplify it. So what we'll get, W, that is equals to P2 V2 minus P1 V1 divided by gamma minus 1. If you recall, we'll get the similar kind of equation for polytropic process, where instead of gamma, N was there. The equation was P2 V2 minus P1 V1 divided by 1 minus N. So simply we will get the similar equation, only this N is replaced by gamma. This W is positive for expansion process and this is negative for the compression process. And as we know, delta U, that is change in internal energy, that is equals to minus W, that is equals to P1 V1 minus P2 V2. This magnitude depends upon the type of process, where the compression is there or expansion is there. So I hope, student, this formula derivation is very much clear to you. Generally this derivation is not asked in the exam, but it may possible that under worst circumstances this derivation may be asked. So final summary is, the process law PV raised to gamma is constant. The relationship between the temperature and volume is TV raised to gamma minus 1 is constant. Temperature pressure relationship is T2 by T1 equals to P2 by P1 raised to gamma minus 1 by gamma. Work done, that is P2 V2 minus P1 V1 divided by 1 minus gamma. This is positive for expansion, negative is for compression. Internal energy delta U, that is minus W, and heat transfer is 0. Now this is the time to solve the numerical related to adiabatic process, last numerical related to non-flow processes. Then this is the end of this series. Only the remaining thing is some important questions, that is our next video, important questions for a property of gas as per your end semester exam or internal test is concerned. Numerical data: 1 kg of air, initial pressure 100 kilopascal, initial volume 0.1 meter cube, expand adiabatically to the final volume 0.2 meter cube, find out the final pressure and work done. Take gamma equals to 1.4. If these two values are not given in the data, you have to remember and you have to write it. So here clearly mentioned adiabatic expansion process is there. Initial mass, that is 1 kg, initial pressure 100 kilopascal, initial volume 0.1 meter cube, final volume 0.2 meter cube. We have to find out final pressure P2 and work done. So we know this relation, P1 V1 raised to gamma is P2 V2 raised to gamma. So we have to use this relation. We know the P1, we know V1, we know V2, we know gamma value 1.4. So when we'll put all the values, we'll get the P2 value, that is 37.9 kilopascal. Simple. And the formula for work done, that is P2 V2 minus P1 V1 divided by 1 minus gamma. We know P2, we know V2, we know pressure, initial volume. So all these values are available. Gamma value is 1.4. So you put all the steps. So 7.58 minus 10 divided by minus 0.48. So it is minus 0.242 divided by minus 0.4. It is almost 6.05 kilojoule. So your two answer, first answer P2, that is 37.9 kilopascal, and work done, which is a positive, that is 6.05 kilojoule. So this is about solution of the numerical. I hope these numericals are very easy. Only important thing is you have to maintain the unit, you have to use calculator properly, and with cool mind you have to solve it. So this is all about different non-flow processes. Now we will meet next time with important questions related to this chapter for your end semester examination as well as for internal test. Till then, thank you.